So the idea behind this idea of good views and bad views, let's establish this concept that we're going to stand in the center of the floor plate on any given floor, and we'll draw imaginary lines from that, vectors, or what will be lines, and if they intersect with a building nearby, we'll consider that a bad view because it's a restricted view, and if it can see beyond these buildings to other buildings or park spaces, that kind of expansive feeling of being able to look into a view shed, then we'll consider that a good view. So the first thing I want to do is I'm going to turn off our geometry. Excuse me, gotta go get over here and turn the preview off, because we're gonna find that we already established this idea of a center point when we made the rectangles, but we actually have another shortcut that we can get to find a center point there. It's really a centroid. It's a center of mass, and that'll always show up whether no matter what the geometry or shape is. It'll always try to put it in what's called the center of mass. So it's a very convenient function. You can find that in geometry under solids, and it's called a centroid, a solid centroid. You put the solid in and you get a point out of it. And I'm just going to feed that geometry then into that solid, and I'll hit run, and we get those center points. And so while we're here now, the next idea is actually to make a line. And we want a line by a start point, a direction, and a length. So let's see if we can just go through and find that. Let's see, we go to curves, line, and then by start point, direction, and length. And our start point is the centroid. The direction and length, actually, we probably don't need to establish, but what I'm going to do is I'm going to add a number to the length of the to that line, just so it's very significant. We'll call that we'll make that 1,000 feet, and I'll pull that in a length, but I won't specify the direction. I think the direction will have, I don't know if it needs that vector. Let's try to run it without it. And I don't think it's not airing out, but it's just not doing anything. So I'm going to have to give it some kind of a starting vector. So let's give it a y vector. So let me see if we can find vectors here. Abstract vector, and I'll feed it. I'm going to grab a couple. We're going to need a couple here. I'm going to grab the x the z and the y axis. We don't need the x. And let's just feed the y-axis in and see if that'll give us I don't think that'll work. I was hoping that might just give us one indication of it. Oh, yes, it does. Good. So there we have a vector in one direction, and you can see it's going right across and striking the building. If I hold the escape, I can zoom out here a little bit. And so you can see that, hold on a second. I'm going to cross my arms here a little bit. Let's rotate around a little so we can see that. So that vectors are just shooting out in the, what was it I established? The y direction. So that's only one vector, and that'll give us a really limited view of what's going on. So there's actually a tool, it's called vector rotate. Let me see if I can figure out where that is. We got vector, and we have rotate, and we have an axis and a degrees. So we have a way of actually rotating that vector a multiple amount of times. Let me just move this over here. So we're going to take feed a y vector in. That's the direction we want it to be. And we need the axis, which is the z. It's going to go up vertically. And then we need the idea of a number of degrees. So I'm going to put in a series using a code block. So that idea of the code block is just a convenient place to enter all kinds of things. So we're going to go from 0, ... to 350 degrees, not completely 360, ... by increments of 10. All right, and so that'll give us, well, it won't give us anything yet until we run it, but I'll go ahead and Let me just scoot out here a little bit. I'll put that down here. And we'll feed that in for our degrees. And we'll hit run. And that did not do what I hoped it would do. Oh, I didn't finish wiring it. I need to put it, I leave it over just here. If we look at the list, we have all of those vectors, but they're not being fed into the line itself. So I need to put that into the direction. And now hopefully if I cross my fingers and hit run, now we get that vector stretching out over 360 degrees. And you'll see what's happening right now is that it's only doing one per spot, and that's because of the way this is set up, the lacing of it. So I'm going to change the lacing until it is now the cross product, and I'm going to hit run again. And now we get all the lines for each one of those points. And so just so you know what the series is, if we look down here, let me zoom in here a little bit. We have from 0 to 360, 36, and increments of 10. So we have a whole bunch of vectors stretching out. And if we, let me hold the escape down here and do a little rotation so you can see. So now we have this idea that sometimes it's intersecting buildings and sometimes the vectors are passing by. So now it's just a matter of figuring out when a line strikes a building, and through computational geometry we have just the sort of tools to do that with.